Anyone think they can tell me what scientific notation is? Because you've probably learned it. Jameson, get your notes out. Elijah, get your notes out. Okay, so put that away. You don't need that. Put it away.
You don't need your iPad.
Yeah. No, put the iPad away. Because you have paper notes. There we go. Oh, we're just waiting for you, Jameson.
I'm on my notes.
Now you are. Yep. No, you have not. I'm watching your screen. Watch. Move your screen. Move your screen right now.
What is that?
Look at that. Look at that. All right. It's so sad that I have to babysit you guys with your notes. Okay, scientific notation. Write this down. Okay? Yours won't load. Can you close out completely and try again? Well, can you restart? Did you? No, but close it out. Double click. Nick, do the, swipe it away completely. Did that swipe it away? Bottom up swipe? All right, can we start?
No.
Let's start. I would love to. Okay, it's been a minute and 36 of this. So, here is what you're doing. Nick, if it's not working, just get a blank note out of notes or something and write it down. This is a compact way of writing. I tell my kids that all the time. Suck it up, Buttercup.
Are you recording?
I am recording. Very large or very small number. Okay. This gets used a lot by scientists and mathematicians. So if you're ever, considering being a scientist or a mathematician, you're going to live in this world. But basically, we're taking a huge number and making it compact, right? Smaller. Or we're taking a tiny number and making it compact, making it a set format. Okay. Scientific notation. So, for example, this first problem here, it says the minimum distance from the Earth to Mars is approximately 284,000 miles. Now, that's not a huge one. You'll see bigger ones than that. But that number, the goal is we're trying to make it a number. Maybe you want to write this up here. A number between, anyone know?
1 in 100.
Not 1 in 100.
1 in 10.
1 in 10. A number between 1 and 10. That does not include 10. Okay, so less than 10. Greater than 1. It could be 1.0, I guess. So a number that's less than 10 is the best way for you maybe to think about it. And then it will always be times 10 to some power. Okay, so we're trying to find a number between 1 and 10 to start with. So if you look here at 284,000, right now, where is your decimal point? At the very end, behind the zero. Okay, there's a decimal point right here. They don't ever write that number in, but it's there. Okay, what you're going to do is you're going to figure out what would I have to multiply or divide this number by to get a number between 1 and 10. Okay, and the way we do that is we move by tens. So 1, 2, 3, 4, 5. Okay, what number, if I move my decimal point to right there, what number do I have? 2.84. The zeros you can ditch. Okay, we don't need to worry about the zeros, but this would be 2.84. But 284,000 is not the number 2.84. Those are very different numbers, right? So we have to tell this 2.84 what has happened to it, or what we need to do to it to make it the number we started with. So 2.84, and it's always going to be, every single time, times 10 to some power. Okay? Now, let's think about this. If I were going to make 2.84 a much larger number, like 284,000, Do I want my exponent to be a positive number or a negative number?
Positive.
A positive number. 10 to some power. I'm multiplying this by 10 to the 1, 2, 3, 4, 5th power. Think about what 10 to the 5th power is. If you want to plug it into your calculator, 10 to the 5th power, and you get a number, 1, with how many zeros behind it? 10 to the 5th power. 5 zeros, okay? So if I'm doing 2.84 times 10 to the 5th, what happens is that 2.84 times 10 to the 5th would go 1, 2, 3, 4, 5 numbers bigger to get us back to 284,000, okay? So here's what I need you to remember. Do we want to go to that now? We're going to go to that now. Come down here. Sorry. Go to this step 1 down here. We're going to write in use Lars, but I want to introduce you to Lars before we do the rest of these problems. Left, you add. Right, you subtract. Left, add. Right, subtract. LARS. So that acronym should help you a lot. Left, add, right, subtract. Because if you come back up here, in my starting number, I went left. 1, 2, 3, 4, 5. I went to the left 5. We said left, you add or subtract? Add. Lars says if you go to the left, you add. So think of everything as starting at 0, 10 to the 0 power. If I'm adding 5 to that 0, it's going to be a positive 5, okay? So if you're moving to the left from your original number, you're going to add 5 to your exponent. If you think of everything as starting at 10 to the 0, because 10 to the 0 is what? 1, right? So we're not changing the value. If we multiply something by 10 to the 0 power, we're multiplying it by 1. So as we go to the left, as our number gets smaller, our exponent gets bigger, if that makes sense, okay? So then look at this one. This one, you would have to move how many places to the right? 6, because we want a number between 1 and 10, right? So this is going to be 2.68. We moved to the right, so we're going to subtract our exponent, which means if we started times 10 to the 0 power, and I moved, what did I say, 6 to the right, what number? -6, okay? So just keep in mind, it feels kind of backwards to me. I don't know. Scientific notation is always it tricks my brain a little bit. If I have a number and I make the number smaller, like I did on this first one, right? It was 284,000 and I made it 2.84. If I make my number smaller, I make my exponent bigger. If I make my number bigger, then I make my exponent smaller. Does that make sense? So take a look at this. If we have the number 75 million, okay, right now your decimal point is here. You're going to move 1, 2, 3, 4, 5, 6, 7. Okay, so 7's going to be our number that we moved. This is 7.5, and it's always times 10 to some power. Is it a positive 7 or a negative 7? A positive 7. If your number got smaller, 7.5 is smaller than 75 million, right? If your number gets smaller, your exponent gets bigger. You try 3 and 5. See if you can write 3 and 5 in that format.
You said 3 and what?
Nick, try your notability again. Why do you have your iPad out again? Put it away.
I'm saying the time.
Uh-huh.
I
I have a clock right there. Mm-hmm.
What was it, 3 and 5?
3 and 5.
Yeah.
It's good, Sarah. Good, Kiana. Logan, will you show me your 3 real fast? I can't see your. Good. Okay, so it looks like we're doing a good job so far. What did you do on number 3?
Moved over 2 spaces to the left.
2 to the left, so 2.08, which is times 10 to what power?
Second.
The second power, the positive second. So you made your number smaller. 2.08 is smaller than 208, which means your exponent got bigger. Okay? What'd you get on number 5 then?
9.07 times 10 to the third.
9.07 times 10 to the 1, 2, 3, 4, 5 to the 5th power. Okay? That second set goes the other way. Those were decimals, and we're going to make those numbers bigger. So 1, 2, 3 gets me a number between 1 and 10, right? 8.52. Your number was a teeny decimal, and now it's 8.52. So your number got bigger, and as your number gets bigger, what happens?
The thing goes lower.
Your exponent gets smaller, okay? So 8.52 times 10 to the what power?
Negative third.
Negative third. Okay, question on number 4. Because number 4, technically, you should always have a decimal point in there. So if I'm going to move this one over to make a number between 1 and 10, it's going to be 4 point what? What's behind that?
0.
A 0. Okay, put that 0 in just so that we know where your decimal point falls. 4.0 times 10 to what power?
Negative second.
The negative second. Okay, so if your number gets bigger as you move it, then your exponent should be smaller. Make it negative in this case. Okay, so write down number 6. What do you get there? Ten to what power?
10 to the negative 6.
To the negative 6. So 6.1 times 10 to the negative 6th power. Okay, so that's if they take a number and say put it into scientific notation. But what if they give you a number in scientific notation and they say write it in standard form? Standard form is like what we saw on all those first problems. That's standard form, okay? Without plugging this into a calculator, if I'm saying 2.54 times 10 to the second, okay, so a positive exponent, means I'm multiplying. What is 10 to the second? What's 10 to the second power? 10 times 10. It's 100, right? So we're multiplying something by 100. Is that going to get bigger or smaller? Bigger. So if I multiply and my exponent is positive, I need to make my number bigger by moving my decimal that many places. So 2 places here. John.
Is it 2?
It would be 254. So standard form of this would be 254. Okay. Look at number 8. 6.7 times 10 to the negative second. Where is your decimal point moving? To the left or to the right? It's going to move to the left. It's going to get smaller. So you have your 6 and 7. You're going to go 1, 2 to the left. So put a point there. If there's nothing there, you got to put zeros in. Okay, so 0.067. Okay. You do 10 and 12. You guys are great. I really like you.
Thank you.
Good, J-Mo. That's good. Kiana, that looks good. So if your number is a negative, where does your decimal point move? The other way. Yeah. Okay, so this right here, right, 10 to the negative fourth, you should be thinking, I'm making it smaller. Whenever that number goes negative, we need to get a smaller number than we had here. So if it was 5.88, and I need to make my number smaller, I'm gonna go 1, 2, 3, 4, which means I gotta drop 3 zeros in there. So you should get 0.000588. Okay, Lars helps out here. You go, if you're going to the left, you're adding. If you're going to the right, you're subtracting. So if this was 5.88, well, maybe that doesn't help in this case as much. Is that more confusing? Because you're thinking of it in reverse of what you did? Maybe that's more confusing. Just keep in mind, if it's a positive number, like 10 to the second, that's you're multiplying by 100, it should be getting bigger. So if you have a negative exponent, you should be getting smaller, okay? Maybe you have just like a, for lack of a better word, like a dummy question, like I'm gonna do 2.3 times 10 to the second power because I know that 10 to the second power is 100. Like just give yourself a simple version of something you could do in your head. 2.3 times 100 is gonna get bigger, 1, 2. If that's a positive 2 gets bigger, then a negative 2 should be getting smaller. So move it the other direction. That might be a good way to think of it. You can disagree if you don't think so. Okay, questions on any of that? What'd you get for the last one, number 12? 0.038. So you take that 0.38. Sorry, I wrote that wrong. 0.38. You take that decimal point and you move it 1 to the left to make the number smaller. So 0.38. Okay. Okay. Take a look at number 13 here. This is a little bit tricky because you're going to see, like on these ones, we're adding with exponents, whereas down here, we're going to multiply with exponents, okay? And just like what we did with our exponents in general before, those are different things. You treat them differently. So just like we did before when we were adding, you need like terms, okay? So 3.4 times 10 to the second plus 5.2 times 10 to the second. If these are not the same, 10 to the second and 10 to the second, you can't do it, okay? So what we're gonna do is, because these are like terms, all you have to do is add that first part. Take this and add them together. What do you get? 3.4 times 10 to the second plus 5.2 times 10 to the second. You get 8.6, and then you just keep times 10 to the second. So it's very similar to what we were doing early on with adding exponents, okay? You have like terms, add your exponents, that's what you get. Nick, will you try and open your thing again? See if it's working. Where it's a little bit different is one like number 14. Are these the same like terms, if you will? They're different, okay? But you could make them the same because we just talked about how you rearrange these. So if you have 9.5 times 10 to the 7th and 1.1 times 10 to the 6th, either make one of them 10 to the 6th or the other one 10 to the 7th so that they match up, okay? I did 10 to the 7th, so we'll just stick with that here. If I'm gonna make 1.1 times 10 to the 7th instead, think about it, we're at 6, I'm gonna make that number bigger, which means I'm gonna do what to the number out in front of it? I'm gonna make that smaller because I made my exponent bigger. So I'm gonna go back 1 and go 0.11 times 10 to the 7th. Okay, so ditch this and just rearrange it. I don't do a ton of this, so you don't need to stress too much about this one. So now your new problem is 9.5 times 10 to the 7th plus 0.11 times 10 to the 7th. How do you do that problem? Yes, so what are we actually doing with it? What do? You add those two things. You add your two things out in front, but you keep your times 10 to the 7th the same. Okay, so we're going to add these two. So it's going to be 9.67 times 10 to the 7th power. Okay, so when you're adding scientific notation, add the front number, if you will. Leave your times 10 to the whatever power identical to each other. You keep that same times 10 to that power.
How'd you get 9.67?
I took the 9.5 and I added 0.11.
Would it be 9.61?
Sure would. You're right. 9.61, my bad. It's a 1. Can't read my own writing. Thank you, Elijah. Sorry, 9.61. Does that make sense? Okay.
I have no idea about that.
How I got what?
Yeah, 6.
This one? 3.4 plus 5.2. Does that make sense? Okay. Okay, jump down to the bottom. We're just gonna do... Let's do 25. Okay, look at number 25. You can still use Lars. Okay? Left you add, right you subtract. Okay? This is all multiplication, and you're allowed to multiply different parts, right? So let's multiply in whatever order we want. Let's multiply this first. 2.8 times 1.9. And you may use your calculator for that. 2.8 times 1.9. You get 5.32. Okay? Now think about this part. You have 10 to the 7th and 10 to the 4th. If you think of it like this, 10 to the 7th times 10 to the 4th, we've done a lot of this, but with a variable instead of a 10. What did we do with the 7 and 4? You add them, right? It's like saying x to the 7th times x to the 4th is x to the 11th. Well, now the only difference is we have a 10, but it's still the same thing. You do 10 to the 11th. So this is 5.32 times 10 to the 11th power. Okay, so multiply the numbers out in front, add the exponents that are the power of your 10. Okay, let's do one more of those. Look at 26. This one has the negative. Is that, you're talking about negative exponent? Yeah, yep. So 26, what are you going to do first? It's multiplication.
Multiply 1.3 times 4.7.
Yes, 1.3 times 4.7 is 6.11. Okay, scientific notation is always going to be times 10 to some power. What power? To the 4th power. 9 plus a negative 5 is 10 to the 4th. Do you know how you can check these? Plug it into your calculator. If you plug this in parentheses times this in parentheses into your calculator, you should be able to get some number and convert it to this scientific notation, and they should be identical. Okay? So you can always check it in your calculator. The one that's a little bit fancier, you don't even need to write this down right now. I'm just going to show you. If I multiply these, I get 28.9 times 10 to what power? The 4th. Is that scientific notation? No. You got to move this. So 2.89. Now tell me, we moved to the left. Do we add or subtract an exponent? Lars, left you add. So times 10 to the 5th. Okay, but if you can just remember a number between 1 and 10 times 10 to some power, that's hugely helpful. That's Mr. Sprick.
Yeah.